All right, so now that we know a little bit about what XSS is and some of the attacks that are possible with XSS, let's talk about some of the defenses for it. So the first thing is, um, you know, how can this happen, right? How can XSS happen? That's kind of what we've been discussing, but let's go over it just to recap a little bit. So remember, this can happen from HTTP requests from the user, right? Query parameters, form fields, headers, cookies, file uploads, and this is mostly the reflected type. It can also come from data from database. This is the stored type of XSS. So remember those two types that we talked about. So, again, if it's from a database and we're using forms to store some data that we're later going to render to a user, who knows where that data, how it got into the database. And essentially it's, if you're worried about security, which it should be, of course, then it's not okay to just trust that, just trust that nothing can go wrong, right? Or to leave that responsibility completely 100% to the browser, right? So we actually wanted to take some steps ourselves to mitigate some of that. And also it can come from third-party services, which I think it's the most prevalent. So like, let's say you install some extension or using some library, anything like that, especially as a developer where we're constantly using a lot of libraries just to build our applications. One of those libraries can have a vulnerability, and it might not be in a malicious way. Like, it could just have been there. And again, like it's just maybe not fixed. And, this happens, I don't want to say all the time, but it's happened before. So again, it can come from third-party services, and so even if the server gets hacked and you've done everything on your end, but then you're loading some library in, at that point, your users and your website can become vulnerable to XSS attacks. So the first defense that we talked about is escaping, right? So most of the let's talk about this and when should we escape the code base, right? So let's say we want to sanitize some of this code base, whether it's reflected or stored. When should we do it? Okay, when should you be escaping these things? So the best way to think about this, and again, like, this is more like a philosophy more than anything. It's always on the way out, right? At render time. And why? So like, let's say if your application is small and you're the only one working on it, that's perfect, right? But again, even then, you could be loading third party libraries. So at that point, even if you don't know that you're working within a team, essentially you are, right? Because you're trusting all these other developers that you're loading their scripts in, that their code is also safe. So one way just to mitigate this, and then just think about it from here on out the same way, is just always sanitize it on the way out, right? As before you're about to render, just assume anything could be compromised, and then just do it before you're about to render. That way you can just, it's a good philosophy to adopt. And then I would say just get used to thinking in that way, and it will at least get you in the habit of a good security model for you to think of. So the other thing is, use the default that comes with whatever templating language you're using. Earlier we showed how you can do this in EJS, but even in React, pretty much every language or every platform or every templating platform, it's gonna have a way to escape it, right? So in EJS template, here with the equal sign, we showed how you can escape it. Remember, if you put the minus sign, then at that point it'll run the code. But again, all the major libraries bring this, and again, just use that as well, right? Instead of actually, maybe like creating your own way or just hacking it. Just if you're using a templating language, know that some of this is already built in, and then that should give you some peace of mind. Let's continue on here. So another philosophy that I want to impress upon you is that, remember that the chart I showed you, where as far as attacks are concerned, XSS is one that's pretty prevalent, right? So one of the things, it's just one of the most common vulnerabilities. And one of the things that we could do, it's like, how can we defend our sites, in the presence that XSS is as big a vulnerability now as it's ever been, right? So remember, with XSS, the attacker code is running on the same page as the user data, right? So at that point, it's kind of like anything goes, right? So they have access to the cookies, other private data, whatever. As long as an attacker is running code on the user's browser, at that point, like, it's kind of game over. So how can we prevent this? Knowing that, like let's just go into it thinking like, what, this is probably going to happen. But even if it happens, what can we do to prevent it? So the key idea here is a concept that's known in security as defense in depth. Okay, so instead of us focusing just on like one defense, what we're going to try to do is we're going to try to apply multiple defenses. So that way, if the attacker gets access to something, then they still have to like get past other defenses in order to to execute the full attack, right? So now the attacker again has to like find multiple exploitable vulnerabilities, and then this makes it harder. At least you mitigate the damage. One example where you see this all the time, and it's becoming more and more popular, is two-factor authentication. Right, so let's say you forget your code or your password or something, and you're trying to log in. You can reset the password, and let's say someone has access to your email, so they'll be able to authenticate it and all that stuff, right? But then maybe they also need to have access to your phone, and then they're gonna send you a verification code that goes only to your mobile number, right? At that point, the attacker actually needs to have both of those things in order to take over the identity and in order to execute the attack correctly. So again, that's so that's the key idea right there with defense in depth. Also, let's talk about defending the user's cookie, right? So one way we talked about it's so now that we have this concept, let's see how we can apply it and layer these defenses on. So the first one is, remember we talked about cookies. So one way to just defend against this is make it just HTTP only. So if you remember back from earlier sessions, that stops the attack that we're seeing right over here. So the one I'm showing right here, so new image source, and then where the attacker is kind of sending the cookies out, through the image, and essentially exploiting that vulnerability. Then once you make it HTTP only, remember it won't be able to get read as JavaScript, right? So that's the first defense that everybody should be using now that we know about this, right? And then that mitigates a lot of session hijacking and things like that when it comes to identity on the web. The next one is content security policy, right? CSP. So CSP, this is a new header. So previously we talked about ways to tie up same origin policy. Now what we want to talk about is in terms in which sites could post forms to our site or load images, scripts, or styles from our site, okay? All right, so let's talk about content security policy, or CSP. This is a new header that I want to introduce you to. Whereas before, remember when we were doing cross-site scripting, we talked about the same origin policy in terms of which sites could post forms to our site or load images, scripts, or styles from our site. So, anytime anything was coming from another site, we would prevent it with the same site header, if you remember that. That's preventing other sites, right, from making requests to our site. And that seems logical because if you remember, when someone can kind of load a script into our website, then that becomes vulnerable. But CSP is actually the inverse, right? So what we're trying to do with CSP is prevent our site from making requests to other sites. Okay, so now this is from our site making requests to the outside. And you might ask yourself, like, why would we want to do this, right? It kind of seems like a good idea that, like, let our site make any type of request. But remember, what we're trying to prevent here is with XSS attacks, what's happening is that someone has code running on a website already, right? So the attacker has gotten their code to run on a victim's website. And then at that point, they can make external requests, for example, and then leak some data, right? So that's kind of where you want to prevent that, right? So when you're dealing with an XSS attack, that's why CSP comes into the picture, which is you want to prevent your own website into making requests to the outside to other websites, right? So that's kind of the inverse of what we talked about with the same origin policy, right? So this is a new header, like I said, and it's called content security policy. You set it in the response, okay, and it allows you to do is it allows you to control the resources the page is allowed to load, right? So CSP blocks HTTP requests, which should violate the policy. So in this case, you're the one setting the same origin policy, right? So since by default, your website can make requests out to kind of anything and load whatever you want it to load, right? So through script tags, style tags, whatever. At this point with CSP, it gives you some control over what resources do you want to like if someone's trying to make a request, right? So if you're trying to load something from an external request, then you get to control that. So let's see how we can do that. So the goal here is let's say we say, hey, you know what? Only allow requests to happen if they're to our own origin, right? So like let's say they're trying to leak some data out through this attack here, right? So they're gonna use they're gonna load an image, and then through that image, then they're going to leak out the document.cookies. Okay, perfect. So what we can do here is we can set the content security policy and the default SRC to self. So now, even if they're trying to make an external request and leak out something, then that won't be allowed because that's to a different origin, right? So instead of, again, working in reverse where someone's making an external request and trying to make the server serve something, this is coming from the inside, and then you're setting the policy and you're saying, hey, you know what? We don't want anyone to make external requests if it's not to our own domain. Another goal is content that comes from our site plus the trusted subdomains, right? So like, let's say, for example, that you want to load, I don't know, Google Analytics, right? So at that point, you might want to say, okay, I have a lot of content that most of the resources come from me. But let's say you're using a CDN and you want to load stuff from externally from the CDN because you're caching, or you want to load it in Google Analytics. Well, at that point, that's not the same origin. So how do we fix that with CSP? Well, the way to fix that is you add a star, and then you get to add any trusted subdomains, right? So you get to have like a whitelist, essentially, of domains that you want to trust, right? Now, one thing I want to caution you before deploying CSP, it sounds great, right? And like now we have this way to mitigate XSS attacks, but now, again, we have a problem. So how do we figure out what the policy should be, right? Because like at any point, it's very fragile, right? Like what if we're missing something, right? Then at that point we can, like if you just apply the policy right now, and like let's say you had Google Analytics running, then that will break your Google Analytics, right? That will break your CDN. So there are many things that you have to consider when applying CSP that might make it fragile and might make it not worth the time, although it does stop XSS attacks, and it is a great policy. So what's the solution? So the solution is, there's a few solutions. So the first one is we can deploy it in report only mode, right? So that's, again, another header called content security policy, and then add report only and then the policy. So what this would do is, it won't necessarily stop it, but what it will allow you to do is it will allow you to get a report every time an external request is being made, and then at that point you can decide what to do. So over time, what you will see is, instead of like making guesses in a vacuum, this way, as you build up your report will tell you all the external requests that are going out, and then this way you get to see what's happening, and then that way you can make a pretty robust CSP policy that actually covers your use case. So again, now that's one way to detect XSS attacks. So how do we catch XSS attacks that our CSP blocks so we can fix the root issue, right? The solution is enable policy violation reports. So not just can you enable it in report only mode, right? So, and this is the way to do it. You can put the default source to self, okay? And then pass it in a URL or a URI that the report can post to, okay? And then this could be in your own server, and then you can save it to your database. Like, this is what I would suggest you do at the beginning, and this is the way to set that the report only on your content security policy. You set the default to self, and then you give it a report URI, and that's what you include in your response header. And then this way, you will get a report every time, and then you can decide what to do with that report at that time. So if it's like Google Analytics, then you can add that to your whitelist, and then there's no issues, right? Now here again, so CSP it's actually pretty in depth, and it's pretty like involved. But I just want to go over some of, like, we don't have time to go over every single one, but I just want to make you aware that, like, this is how complex complex the policy you can make it, right? So you can make it as unique as your use case is, okay? So the default source, this is the kind of the default thing that serves as a fallback for the other directives. So if you include none of the other directives and you just include default source, it'll kind of stop like, everything, you know. But there is also a connect source. This restricts sources from script interfaces. Font source. So if you're like, you know, if you're making a request to load in fonts, you can create a whitelist of fonts. The frame source, this restricts sources for nested browsing context, so iframes and things like that. The image source, you know, if you're making an image request to an external site, then that's you know, you can set the policy to not allow that or allow that, and provide it a whitelist. Media source, so again, this is for audio and video. So, you know, again, it's like I said, it is pretty involved, but probably the most important one, it's this one, which is script source, and this restricts sources for script elements. Okay, so that's, you know, again, read into CSP. It's a great policy. It is a way to stop XSS attacks, but it is kind of you know, it is kind of fragile in the sense that if you miss something, right, you can be breaking something inside that you didn't intend to, and has nothing to do with XSS, right? Because it is so restrictive. Okay. Now, the other thing that that it does is that script SRC blocks inline scripts, so it doesn't just block someone from loading in a script tag from the outside, right? And that's kind of what we were expecting, but because when this header was created, the purpose was to stop XSS attacks. Then if there's an inline JavaScript, okay, injected into the website, by the mere fact that it's inline, then script SRC, this CSP policy, would actually also block all inline scripts. Okay, so the better solution for this would be to move the code, instead of writing it inline, move it to, you know, to a file that's hosted on your site, and then load it in that way. That way it doesn't get blocked just because it's inline. But again, this is something you have to know, be aware of it. There's a lot of like gotchas and caveats when it comes to CSP. Yeah, so there you go. Now, because of all these caveats, there are like, you know, and like since this has been implemented, there's a lot of breaking changes. So a lot of people are shying away essentially from using CSP as a way to do it. But there's a better way that we can accomplish kind of to stop XSS attacks, but at the same time make it dynamic enough so that, like, let's say we're trying to load Google Analytics, right? But then Google Analytics has other scripts that it's loading from, like, let's say other servers that they have, but you didn't include that in your whitelist, right? So now again, you go back to the point that it's, you know, it's great when it works, but it's very fragile because you have to take into account all these edge cases, right? So is like the question is then, is there a way that we can mitigate, okay, so that we can propagate? Once we say we trust the domain, like anything that domain loads, then we're going to trust it as well, right? So it's kind of like a blanket statement. Once we say we're going to trust one origin, then anything coming from that origin, you know, images, scripts, whatever, we're going to trust it as well, right? So this allows us not to have to specify all these whitelists and to not have all these edge cases. And the way to do this is after your script SRC, you pass in strict dynamic, and then you set a nonce, okay? And the nonce, essentially what it is it's a dynamic value that you can set, and any script tag, okay, that you include on your site later on that you're loading, as long as it has that nonce value, then it'll be allowed, okay? And then that way, that's kind of that kind of sets it so that you don't have to set the whitelist anymore, right? So no need to specify that. The nonce, like I said, it's a dynamic value. So although right here in the example I'm showing nonce ABC123, again, like this could be randomly generated, and we've talked about how to like do secure random generation in previous lessons. So if you forgot how to do that, then go back. But you can essentially generate a random nonce, and then on the client side, any script that has that nonce would get whitelisted implicitly, right? Like you do not have to do it on the server side. All you have to do is pass in strict dynamic, pass the nonce and the value of the nonce, and then on the client side include that nonce with every script that you yourself want to allow. So if an attacker actually does get some code into the into a user website or into a user context, because the attacker won't know what that nonsense is because it's been randomly generated, and it's, if you do that correctly, it'll be very hard to brute force that and like guess that. Then that way we kind of get we kind of get the best of both worlds. We can stop the XSS attacks while at the same time not have to deal with all the edge cases that come with CSP. Okay, so here I went ahead and looked at and got for you kind of a starting boilerplate. So if you don't know where to start with a CSP, here's a good policy to start. But again, remember, every use case is different. So and yeah, of course, with this course, all the slides are included, but so you don't need to just copy it, just get it from the slides. But this is a good starter. This is a good starter CSP header, and I say reasonable because this is crazy, and it just kind of gives you an idea how like complex CSP is. But this is a good one though. Like this was one you can if you don't know where to start, use this one, and then as other edge cases arise, then deal with them then. Okay, but this is a great one to use for yourself. So feature policy HTTP header. So there are other policy that which is there's another header that you can set, which is called feature policy as your response. So again, this one's like not as this one also stops XSS attacks, but it stops other type of attacks that I think are going to become more prevalent. Again, this one's pretty new, so I just want to make you aware of it. It's called feature policy. Look into it. But what it does is it selectively disables browser features. Okay, so things like autoplay, geolocation, picture-in-picture, vertical scroll. So these are things that, again, these are more in-depth attacks that can happen not be like with XSS. But again, this is like pretty nuanced. And again, if someone is just doing this to your website, it's at that point, maybe you should look into just look into the feature policy header, okay, because it's also pretty in depth. But as new devices, more and more devices, right, IoT and things like that, you can imagine that. And as these devices are connected to the internet, and as we want to provide APIs, yeah, security is going to become kind of an issue. So we're kind of in this like middle point now, okay? But at least I want to make you aware that these things do exist. So again, what I suggest is follow the links. I'm going to provide links here under the video. So click on those links. It'll give you kind of a better understanding of like these more in-depth subjects. I suggest, again, if you're getting into security, that you become acquainted with this because it's going to become more and more useful. Again, if your company deals with security, or if you want to start a company that deals with security, like these are things you should know anyways, and it allows you to create value for your users. And beyond being just a developer, I think if you're going into like pen testing, yeah, these are things that are going to become way more useful and way more important in the future. So final thoughts on XSS, just to wrap up here. So XSS vulnerabilities are pervasive in the real world. Okay, they're pretty much even with all these policies that we have, XSS is still a problem. There's still probably over 50% of websites on the internet have some type of XSS vulnerability. So again, it's still an issue. But these are like some ways that you can mitigate this. And remember, as you layer these things on, you increase your chances that you won't become vulnerable to one of these attacks, right? So remember the philosophies that we talked about in depth, okay? Like layer your security, use more than one technique. That way the attacker can't just attack one vector. They have to go through many things in order to gain access to, and like make a system vulnerable. Okay, be aware of the context you're including your user data in. So if you do want to include, so for example, like let's say you're using React or Angular or something, like be aware, okay, that someone can actually run JavaScript within those languages and it'll get rendered as JavaScript simply because of the way that templating language is set up. And that's the expected behavior that you do expect. But when we're thinking from a security standpoint, just be aware, okay, that someone can run JavaScript because it's already running JavaScript, right? So the templating language itself, although it looks like HTML, it's actually like, for example, like if we're talking about JSX or something, which is the React templating language, right? That's JavaScript. Okay, it looks like HTML, but it's not. It's JavaScript. So again, just be aware of the context you're using, and you're including your user data in, right? And then one last thing, UCSP. That I think will cover most of the use cases. It will if an attacker is just phishing and just trying to attack a wide range of like websites that are vulnerable, at least yours will become harder, and maybe they will just move away and not deal with it because you have all these things in place. Okay, so anyways, hope you like this part of the course on XSS. I think it's super important, again, because so many websites are vulnerable to this, and it is hard to stop unless you know the defenses. Now that you do, use them, and I think it'll put your site and your users in a place that makes them a lot more safe. Okay, so anyways, hope you enjoy. See you in the next video.